3-4 functions. I can represent functions using tables, graphs, and equations.
All right, so you guys, question. Could we determine a function based on a table?
Yes.
Remember input-output tables, right? Could we determine a function based upon a graph?
Yes.
Vertical line test, right? Could we determine a function based on an equation?
Yes.
Yes, we had to either make a table or draw the graph, right? Okay, so we can now determine or represent if things are functions or not, if graphs are functions or not, if data is functions or not. So first thing we need to do is understand what a function is. Something that connects two pieces of data or two quantities. My example again is if I want 100 t-shirts from Gianna, she's going to charge me how much? So my 100 t-shirts is tied to the $300 I owe her, right? If I ask for one more t-shirt, is her price going to go up? So whatever I ask for, the input is going to change the cost, which is going to be the output. Okay, so input would be that number you plug into an equation, or the x. The output would be the result, or the y. Could there be several inputs?
Yes.
We call that the domain. Okay, eyes up here. Could there be several outputs?
Yes.
We call that the range. And all of those are again going to coordinate or correspond with the x's or the y's in the slope-intercept equation. There are two ways to determine a function, at least in our world. There are two ways to determine a function. We just talked about this at the beginning of the video. One would be to create an input-output table. And a function exists if every input has how many outputs? One. What if an input has more than one output? It's not a function. Okay, and that's what this says right here. Okay, the second way to prove whether or not an equation is a function, or some data is a function, is by using the
Vertical line test.
And the vertical line test states that if you draw a vertical line through a graph equation, it should only intersect that graph equation how many times? Once. If it intersects it more than once, it means what?
Not a function.
It's not a function. Okay, and then you have multiple graphs to view. Okay, so if we look at the first one, look at my input-output table. How many outputs do these inputs have?
One.
Is it a function?
Yes.
So if I graphed that data, which I did right here, and I drew vertical lines anywhere through that graph data, how many times does it intersect the line? Once. So it's a function because of the vertical line test, and it's a function because of my input-output table. So I can prove it two different ways. Secondly, I gave you an equation. This is how we started the problem. I said, use the equation y equals 2/3 x minus 4 and tell me if it's a function. Some of you decided to make an input-output table. Does that work?
Yes.
Yes. And after you make your input-output table, you could graph it. One group, I think, only said, well, I'm just going to graph this equation. I'm going to graph y equals 2/3 x minus 4. So what they did is they graphed the y-intercept, which is what?
-4.
And then they used the slope, which is what?
2/3.
1, 2, 1, 2, 3, 1, 2, 1, 2, 3. And they drew their line. And then they did the vertical line test. And how many times does that thing intersect? How many times do those vertical lines intersect? Once. Okay, lots of different ways to go about that. Look at this table. Is this a function? Why? How many outputs does 0 have?
2.
How many outputs does 2 have?
2.
Yeah, that doesn't work, right? Okay. Is this a function? We plotted, or we first of all, we drew a line right here. We plotted this point, we plotted this point, we plotted this point, and we drew a line. So that's our graph. And then we drew a vertical line right through it. Whoops, a vertical line right through it. It intersects it at the entire graph, right? Okay. And then we also realized that this point is 2 what?
1.
Over 2, up 1, right? This point is over 2, up 4. Already we know it's not a function because each input has how many outputs? 2. Okay. And then the last one, do functions have to be straight lines?
No.
No. Does this look like a function? Look at the graph. Does that look like a function to you? It sure is. If we drew vertical lines anywhere on this graph, would it only intersect that graph in one spot?
Yes.
Yes. Also our input-output table. So this is that. So these are the points we use to make this graph. How many outputs do our inputs have? 1. Do we got it?
Yeah.
If we don't got it, you're at least going to watch the video again and again and again and get practice on your homework.